Good morning, everyone. How are you? Today we will take a new lesson in Unit 3 for Secondary 1 First Term. This lesson talk about the classification of acids, the classification of bases, and some new properties of them. Firstly, we will start with acids. Acids can be classified according to three bases. Maybe on the base of their strength or the degree of ionization, maybe classified according to their source or classified according to number of their basicity. Firstly, according to their strength or degree of ionization, the acids classified strong acids and weak acids. If the acid is completely ionized in water, it is called strong acid, and the equation of ionization is written with arrow, one arrow indicate the product, while the acid which is incompletely ionized when dissolved in water, this acid is called weak acids, and the ionization equation will contain a double arrow in the two direction, backward and forward, because some molecules are ionized and the other no, and this is will be in a dynamic equilibrium. The examples of strong acids: hydrochloric acid, hydrobromic, hydroiodic, sulfuric, nitric. This is a list of strong acids, and it is important to keep or remember these names very well. While the weak acids include carbonic acid, phosphoric acid, acetic acid, formic acid. Mainly the organic acids are considered as weak acids. Now we will transfer to the classification of acids according to their source. If its source is plant or animal, so this acid will be organic acids. But if the source of acid is mineral earth or not an animal or plant, will be called mineral acids. Generally, the most of organic acids are, or all of them are weak acids. While mineral acids, some of them are strong and some of them are weak. And also here a list of organic acids, for example, lactic acid, acetic acid, citric acid, oxalic, formic. While mineral acids include carbonic acid, which is weak, hydrochloric acid, which is strong, phosphoric acid also weak, and the rest of the list. According to the basicity, classification of acids according to their basicity, firstly we must define what is the meaning of basicity of acid. Simply, the basicity means the number of hydrogen ions which produced from an acid. For example, hydrochloric acid, HCl, contain only one hydrogen ion, so it is monobasic acid. Sulfuric acid contain two hydrogen ions, H2SO4, so this acid will be called dibasic acid, while the phosphoric acid, which is H3PO4, it is contain three hydrogen ions, so it is tribasic acid. Here, the basicity of acid, it is the number of hydrogen ions which are produced by one molecule of the acid when it dissolves in water. The replaceable hydrogen atoms can be replaced. And this is a list of some examples of monobasic acid or monoprotic. We can see monoprotic. We can say monobasic or monoprotic acid, dibasic acid, or diprotic, tribasic acids or triprotic. A monobasic acid may be organic, may be mineral. Also basic acid may be organic, like oxalic, or mineral. And tribasic acid also may be organic or mineral. And these examples are very, very, very important and must be memorized as you can possibly. Now we will transfer to make a classification of bases. Bases are classified according to their strength or according to their ionization or dissociation, or classified according to molecular structure. If the bases are classified according to their strength or their degree of ionization or dissociation, this classification will give strong bases or weak bases. Strong bases, also, these bases are completely ionized in water, while weak bases, they are incompletely or partially ionized in water. For example of strong acids, potassium hydroxide, sodium hydroxide. Okay, while weak bases, for example, like ammonium hydroxide. Okay, remember, strong acids and strong bases are completely ionized in water, so they are strong electrolytes, while weak bases and weak acids are partially ionized or incompletely ionized, so they are considered as weak electrolytes. Okay, this is the classification of bases according to their strength. Now we will transfer to the classification of bases according to their molecular structure. There are 4 types of bases according to their molecular structure. Firstly, metals oxides. Secondly, metals hydroxides. Thirdly, metals carbonates. Fourthly, metal bicarbonates. Metal oxides, for example, iron oxide, iron 2 oxide, magnesium oxide. These oxides, when react with acids, for example, hydrochloric acid, for sure give us salt and water, because it is a neutralization reaction between an acid and base. Metals hydroxides, for example, calcium hydroxide, potassium hydroxide, sodium hydroxide, all of which, when react with acids, for example, sulfuric acid, will produce also salt and water. This is a neutralization reaction. In case of metals carbonates and metals bicarbonates, these are bases. When react with acids, for example, hydrochloric acid, they for sure produce water, salts plus carbon dioxide, because carbon dioxide is the main product which produce from the reaction of an acid with carbonate or bicarbonate as bases. Okay. Now we must be careful or notify that the expression of alkali and base, what is the difference between them? The word or expression base is more general than alkali. The base is a total category of basic compounds, while alkali, it is a part of this bases. Alkali, it is the base when dissolved in water. Again, alkali, it is the base that dissolves in water and gives what? Give hydroxide ions. So the alkali are a part of a bases, and therefore we can say all alkalis are bases, but not all bases are alkalis. Okay, how to detect if the solution is acidic or alkaline or neutral solution? For sure, it is depend on the concentration of hydrogen ion and hydroxide ion in this solution. According to the concentration of hydrogen ion and the hydroxide ion, the solution type will be determined. Acidic solutions have higher the concentration of hydrogen ion in acidic solution is higher than the concentration of hydroxide ion, and vice versa. The alkaline solution have a concentration of hydroxide ion higher than the concentration of hydrogen ion, while in the neutral solution the concentration of hydrogen ions equal the concentration of hydroxide ions. So to detect the type of solution, if it is acidic, alkaline or neutral, we may use two methods. We can use indicators and we can use pH meter. Firstly, what is the indicators? Indicators, it is a weak or they are a weak organic acids or bases. Their color change with the change of the solution or the medium type. So this is attributed to that the color of the ionized indicators differ from that before ionization. So indicators depend on the change of its color according to the type of solution. And here we have a table with four of the most famous indicators, which are methyl orange, phenolphthalein, litmus, and bromothymol blue. These four indicators are the most famous one, and their color according to acidic, neutral, or basic medium. This is also very important table and must be memorized very well. Now we will transfer to the pH meter, but firstly, what is the pH? The pH, it is the hydrogen exponent. This is what means what? It is a way to express the degree of acidity or alkalinity of a solution. This depends on the concentration of hydrogen ion or hydroxide ion in the solution. Here, a figure illustrates what is the meaning of acidic solution, neutral solution, and basic solution. Remember, pH is a measurement. It is a measurement. Its value range from 0 to 14. At pH equals 7, it is a neutral medium or neutral solution. Less than 7, it is acidic. More than 7 is alkaline or basic. So in this figure, acidic solution, the concentration of hydrogen ion is higher than hydroxide ion, so the value of pH is less than 7. While the neutral solution, the concentration of hydrogen ion equal the concentration of hydroxide ion, so the value of pH will be equal 7. While the basic solution, the concentration of hydrogen ion is less than hydroxide ion, so the value of pH will be more than 7. Okay, this is the end of this lesson. Thank you for your attention and goodbye.